Hello, my name is Eva Leos, and I'm delighted to be your host for today's FIATech SETI Winter Webinar. This webinar is called Fast Tracking the Most Complex of Buildings, a Healthcare Case. We want to hear from you, so please enter your questions in the question box throughout the session, and we will make time to answer them at the conclusion of the presentation. At this time, I would like to welcome our presenter, Bassel Eschewi. He is a civil engineer with over 28 years of experience in managing the execution of buildings and working as a control engineer on mega projects. He is an expert in CCC's IT application for construction project controls and serves as a division manager of infrastructure and implementation. Bassel possesses a deep theoretical and practical knowledge of lean construction, AWP, and workforce planning. Please welcome Bassel.
Well, thank you, Eva. I'm very happy to be with you today to explain to you how we do project controls in CCC using different methodologies and our in-house systems for room completion. And today I will go through this presentation and we are using King Hussein Cancer Center project as an example. The project, it includes architectural finishes and MEP packages. The duration is around 730 calendar days. Lately we had an extension on that, and it already started, of course, as mentioned here, on 1st of April 2014. Currently we have around 850 persons and more than 40 subcontractors, and as you know, hospitals are complicated type of projects where we have different systems to implement within such project. The hospitals consist of around 182 rooms, and it consists of 2 towers, one of them with 10 floors and the second with 12 floors, beside the ground floor and 3 basement floors. Overall, the total built-up area is around 84,000 square meters. The system which we use to control the rooms and the subcontractors to have for completion got awarded by Site Award for 2016 from FIATech, and that's for the technology and knowledge-enabled workforce, and I'd like to thank all those people behind this award. Room completion system, as I mentioned, is based on different concepts and methodologies, and I will go through those methodologies and the system screens one by one. In this slide, I will summarize the whole cycle, then I will go through each one of those points one by one in detail. So we start with the WBS of the project, which is a work breakdown structure, and we link it to our building information modeling, BIM. It's a well-known concept nowadays, and we go through the scope of work per our crews and per the subcontractors. We define those the scope of work. We go through the finishing schedule, and we define the fragments or templates of operations that we need to accomplish different types of rooms and facades. Once we finish all those preparations, we start implementing our advanced work packaging technique, where we do like 3 months look ahead, and we look for the open fronts by using our front-end loading checklists. These checklists, we are using it in order to prepare for the open fronts and to define where we have open fronts. Then within those open fronts, we work on preparing the work orders for the current week and the coming 3 weeks. So we do like 3 weeks look ahead with it. And once the job is accomplished for a certain subject or a room or a system or an object, we initiate the inspection request for quality control and punch listing. And eventually we track the invoices of the subcontractors and we prepare our payment certificates. So we'll start with the work breakdown structure, where it is a deliverable-oriented hierarchy for a project that will organize the project's teamwork into manageable section. And I'd like to emphasize here the keyword, which is manageable section. This will affect our organization chart at site and how we distribute the work over our crews. So in CCC, our WBS is composed of 7 levels. The first level is the project itself. The second level is the main area. The third level is the sub-area. The fourth level is the discipline. The fifth area, the fifth level is the activity level, which is Primavera activity level. We take it from, we use Primavera for scheduling. Level 6 is the object level, which we inherit from our BIM authoring team, and level 7 is the list of operations that we need to use in order to accomplish that object. And in our example, level 1 is the project itself, King Hussein Cancer Center. Level 2 is the main area, which is building 1, building 2, building facades, roof works, external works, and so on. Level 3 is the zone level. Within each building we divide into different floors and levels beside the stairs, the shafts, the elevators, and those defined areas. Level 4 is the discipline. For each area we have different disciplines that goes or that work together within that rooms. So we have the mechanical, the electrical, the finishing, the buildings, and so on. Level 5, we take it from our Primavera, so it's composed of the activity IDs that we have it in Primavera, so the system is linked to Primavera. Level 5 is the object tagged as per BIM authoring deliverables, and level 7 is the operations that is related to the object type. So in our case, for example, if we have like the object is a foundation, the operation is going to be the blinding, the formwork, the rebar, the concrete casting, the formwork striking, and curing. After we build the WBS, we start creating the model using our BIM authoring team. BIM here, it's an intelligent 3D model-based process that would provide a control tool for all project stakeholders during the project life. And with BIM, we mainly work on building the objects and defining their tags. The key element here is the tag. Each object should have a smart tag that would allow us to use it and to link our model to different topics. So as an example, in case we have here in room or building 1, floor 9, HVAC system, we have duct 001, and even we can add to it a tag for the operation. So the key, as I mentioned, is the project WBS in addition to the BIM tag, and both together they will give me the member mark that I will use within each model in order to link things together. So as I mentioned, the BIM authoring deliverables, which is the object tag and the operation, it allows me to link with the BOQ in order to prepare for the invoices and the payment certificate, to link with our cost elements in order to allow me to do cost control during the project. Also, I can use it to link with the WBS and to feed in the end value within Primavera, so I can do progress monitoring and scheduling. in addition to link with our quality control and our inspection test plans in order to control the So we start by room numbering. Sorry for that. We start with the room numbering, where we define the room numbers coming from BIM team. And with each room, we define its type. So you can see here in different colors, different types of rooms within a certain floor. For example, we have the patient room, we have the clean store, the corridors, the data room, the electrical room, and others. In addition, our BIM authoring team, they define for us the electrical systems, and we even color those systems in order to emphasize them over the model. So here we have the data system, the emergency lighting system, the lighting, the power, and so on. Also, we define the mechanical systems, and here I can show you how we define and we color our drainage systems, the firefighting systems, HVAC, mechanical, medical, water systems, and as you can tell, we have different types of systems for hospitals. And not even that, even within each system, we define the subsystems related. And in our example here, for the HVAC, we divided into the chilled water return system, the chilled water supply system, the exhaust air duct, the fresh air duct, the lobby pressurized ducts, the return air ducts, and so on. So from both, by defining the rooms as verticals and the systems as horizontal, the intersection between those rooms and the systems, we can get a list of outlets and parts of systems within each room. And this list will help us a lot in controlling the crews and the subcontractors that will go inside those rooms. In addition, for each room, because we know that whenever we have an intersection between different systems and the walls and the openings, it's very important for us to define those openings and to give them a tag and to define the systems passing within those openings. And we even link them to their related subcontractors and crews in order later on, as we will show you in the other screens, how we control the entrance of the subcontractors and how to coordinate in between different subcontractors in order to finish a certain opening. So now we need to prepare for the subcontractor scope of work. In order to do that, we have the EDI agreement we used to do like electronic data interface agreements with the subcontractors in order to align them all according to our BIM need, in order to define their deliverables, and in order to get similar formats within our model. So with each subcontractor, we define their scope of work, the format of the model that he's going to deliver, what are the related drawings and documents, what is the schedule in order to link different subcontractors' operations within Gantt chart, how to link the operations of those subcontractors within a fragment, as I mentioned, or a list of works that comes in sequence within each room, how to provide QC inspection and punch lists for the subcontractor work, how to provide a clearance form to control the relation of the subcontractor with others, and how to control the invoice coming from each subcontractor. So in the EDI agreement, as I mentioned, we define the model format for each subcontractor, the level of detail that we needed during the project life, the naming convention and the tags that each subcontractor should use in his model. And as I mentioned, the tag here should be smart in a way that will allow us to automated link with different topics. And we define also with them the data and the documents related in order to ease the job for that subcontractor. In addition to update the frequency of the data, and we need to agree with him on different types of updates per different types of data. So in our system here, and we call it C3D Planner, the system will allow us to use or to define our subcontractors, to define their scope, their objects, and to define the BOQ related, and to use the model graphically to do these definitions. In addition, we define the scope of each subcontractor graphically, as you can see here. So we identify the system, the subsystems related to each subcontractor or the finishing, and we color them and we show them within the model. Besides that, as mentioned, we take the schedule from the subcontractor and we inherit it within our main schedule, and we distribute the operations within the Gantt chart, and so we will have a global list of operations from that subcontractor and others within each room. And this will help us to define the sequence of work within each room. Also, we give a screen to our subcontractors that allow them retrieve their drawings and documents in order to prepare for the required job. So after we define the subcontractor's scope of work, we start working on defining the fragments or the templates of operations and sequence per each room, because as you can tell, each room has its own operations and there is a sequence of work related to that room. So in order to define this list of operations in sequence, we rely on the best practice, on the method statements if we have certain operations to be done within that room. Beside the material and drawing availability, of course, will affect the sequence of work. We may maneuver in order to speed up certain operations in case we have drawings ready for it, and delay other operations if in case we have late design or material at site. Also, the availability of the subcontractors will affect this sequence beside the site conditions. So for example, we have for this room around 26 operations in different disciplines, and each group of them are related to a certain subcontractor. So we identify them, we identify the subcontractors, we link the scope of work per each subcontractor, we put them in sequence per each room, and we color them. As you can see here, within this room we have different subcontractors working on different operations. Besides that, we list the systems and their responsible subcontractors per opening. As I mentioned before, we already have the openings with their tag and the systems. Now we define the subcontractors related, and we even give them their priorities. And that in order to allow us control the entry of the subcontractors within each room and the work within each opening. So we give priority for the systems that will come at higher level than the lower level and so on. And this will help us a lot to reduce the conflicts and to have a smooth working between the subcontractors. So we end up with a clearance and a delay impact. Here, since we have a sequence of work, we need to list those operations and the related subcontractors. We need to give a tool for our engineers and control engineers at site who will go first, then who will go second. If there is any site condition, how to maneuver and how to exchange between those operations and those subcontractors, how to direct the subcontractor to other open front. And in order to do that, we end up with a clearance form between those subcontractors. So this is a first example showing that for a certain room, the subcontractor has an operation that is followed with the three operations, and each operation has its own subcontractor. And in case we have a problem with that subcontractor within that room, we can maneuver and shift him to another room. Also, for those subcontractors, we can direct them to other open fronts in order not to have a conflict with them. Also, we can put the operations in sequence and follow and track the deliverables per each subcontractor per room. And here we can also monitor the entrance of each subcontractor using a clearance form. So, for example, in case we have, let's say, the HVAC subcontractors working, and before he leaves the room, he should fill for us, and our inspector should sign for him the clearance form, so he delivered the system within the acceptable level. Otherwise, he will make me a problem with the, let's say, the false ceiling subcontractor. So I need these forms in order to control the relations between the subcontractors. So by now, we already prepared all the requirements in order to start our advanced work packaging technique. We prepared the WBS, we prepared the model, we prepared the subcontractors' scope of work, their BOQ, we prepared the room types and their fragments. Those are the work and sequence within that room. And now we are ready to start our advanced work package, where we need to define those areas and even the facades using our C3D 2D map. We define those fronts and we give them number. Those are our work fronts that will later on we need to study their cases, and we need to know who are the crews related, what are the systems related, and who should go first, and if we have all the prerequisites available, so to say it's open front or not. So the same goes here. We use the same technique of the 2D map to define the boundaries of each room. And now for us, each room with its type, we need to define or to link it to a checklist. We call it a front-end loading list that will allow us to detect all the prerequisites, and so to be able to tell if it's an open front for that specific job or not. So this checklist, it's related to the material, to the engineering, to PMV, to HSE, to the quality control, accessibility, site conditions, the HR, manpower, and so on. And within this list, we always look for the service departments related for each item. And we also flag that specific item if it is related to 3 months or 3 weeks look ahead. In addition, we give it an ETA date and the status to follow. So this is an example for our front-end loading checklist. We have different departments, parties, related items, a flag showing if they are 3 months or 3 weeks, and the status for that item. And once those items are cleared, this related room will be considered as an open front. And the result will be, as you can see here in green, those rooms are open front for a certain subcontractor, if we are studying a case related to a certain subcontractor, and those in red are still not ready for him. So after we define the open fronts, and we do like a 3 months look ahead using the open front, using the front-end loading checklist. We start preparing the work orders per each crew and per each subcontractor using work order lists coming out of the system. In order for us to generate those work orders, our progress monitoring engineers, they need to do a balance and study for those items mentioned here. So our progress monitoring engineer, he needs to go over the open fronts, and as we did in the previous exercise. Then he needs to look at the S-curve and see what is the percentage required from our subcontractors and the crews at site in order to give them the amount of work that will tally or that will cover the requirements of our S-curve. The quantities and the objects with their operations coming from them. Also, all crews and their capacity are already defined within C3D system. Besides the work in sequence and that subcontractor specifically comes after whom, and if it's an open front or not for him, besides the site conditions. So our progress monitoring engineer, he needs to do balance between all those items in order to generate the work orders. And those work orders are composed of the objects and their operations. And they are produced for the current week and for the coming 3 weeks. So in his process, he prepares for the current week in order to get the feedback from site in order to calculate the progress and to generate the progress report, in addition to prepare for the 3 weeks. And this is an example for our work orders where we define the objects and their operations, and we give empty columns for our site engineers in order to fill them using a digital pen. This digital pen will allow our system to read the data and OCR them automatically. So we are automating the feeding. We feed our system automatically from those forms. This is a clear example showing for each object and operation what is the percentage and if there was a problem related, and here he can write even the reason behind the problem so we can solve it for him during the week or the next week. And as you can see here, the system did an OCR for the figures, and they are ready to be read by the system. So the end result, it's going to be the progress. So we feed in our WBS, the pyramid we mentioned before, the lowest level, level 6 and 7 with their progress. We calculate the percentages to the upper levels. We do the roll up for the calculations, and we generate the progress per different level. We can do the progress per system, per rooms, and we can color them as you can see here in our example. So those in blue, they are around 75, between 75 and 90%. And we do the same thing per system. We can show the percentage of progress per system. Or we can define the progress per subcontractors according to their scope. Could be per system if the subcontractor scope is related to a certain system. So the output is flexible. We can generate the progress in different ways. Here in our example here, we can show the progress of the subcontractors related to rooms and their finishes. And of course, we can generate our official progress reports per each level. So once we generate our progress report, and once our site they report that they finished a certain object and its operation, the system is linked to another system, we call it C3D Atlas, where we use the system to monitor our quality control checklists and test sheets, and to do punch listing in case we have minimal job to accomplish. So this is an image from C3D Atlas, where it shows that we can track the inspection requests coming from site. We can build the quality control scope, and so we can tell what documents are required in order to finish the job within certain area. We can also prepare the documents in order to prepare for handing over at the end of the project. And this system is very essential for us in order to prepare for asset management later on, once the project is ready to be commissioned and to operate. And the same goes with the paperwork. We can show the progress of the documents, of the quality control documents, what's been approved, what's been tested and approved, what's been rejected, or what's still outstanding. So we follow the physical progress and the supporting documents coming from our quality control department. And we can reflect that over the model. In addition, the system is able to track the punch items related to each room and to each subcontractor and to each system. And those punch items, they are gathered within forms. And lately we are preparing electronic forms within our handhelds in order to feed in those punch items and link them to our model. So eventually, after we finish the progress and we track the quality, we prepare for our invoices. So we need to check the invoice coming from the subcontractors and prepare for our payment certificate. So this is an example for a BOQ with a certain subcontractor. And those BOQs, we code them and we feed our legacy system talisman for each subcontractor, the related BOQ items, and the quantities and the unit of measure related, of course. In addition, we link that system to our C3D system in order to define or to link the objects coming from the model to that subcontractor to its related BOQ item. So the system is flexible and it is able to be linked to any other legacy system that is related to, for example, we can link with Candy and with J.D. Edwards records in order to link the objects to their BOQ items. Accordingly, the system is able to get or retrieve the progress per each subcontractor for a certain operation, and we can show the BOQ item quantities, total BOQ item quantity, the quantity related to that subcontractor within each level, and the percentage of progress, the earned value per each item per that subcontractor. And here you can see this this job is split into between two subcontractors. And we can use the system also to get summary reports. And accordingly, the system is allowing us to do cost loading and to distribute the budget cost and the rules of credits over the operations. In addition, it is allowing us to put our cost elements over the operations. So eventually we'll be able to calculate the earned value and compare them to the actuals. So we can generate a checklist to detect the invoices coming from each subcontractor. In addition, we are able to generate cost report for the current month and the previous month, and we can define the cost per each discipline. And we have different types of cost reports. So this system, the room completion system, it helped us in controlling the subcontractor's job and defining the scope of work per each subcontractor, and it allows us to do better control through the model, using the model and the takeoff, using the tag concept in order to link things together. This helped us to generate our progress reports graphically and in figures. In addition, it allows us to check the invoices coming from the subcontractors. Besides that, it allowed us to generate our payment certificate. And we can apply the same concept using the advanced work packaging technique, the front-end loading technique, and the fragnets, using the systems that we have like C3D Planner, C3D Atlas, Talisman, VBC for EDMS. We can link all those systems together in order to help us control and follow the job per each subcontractor, in addition to follow the progress of each room and the completion of each room. And we can implement the same concepts on other subjects, like in case of oil and gas projects, we can do that for pipe racks inside the factory. Or we can implement the same concept for underground cable trenches. In addition, we can use it to study the case of equipment and the surrounding pipes and foundations. Also, we can use it for metro viaducts. The same as I mentioned here, the rooms for a building, or the facades, or the external works for a building. Also, we can use it to study the tanks and the surrounding services. We can even use it to study the earthworks and divide the earthworks into cubes and work fronts. And we can control that for different types of projects like roads. So it's an open subject, and this room completion system is able to be implemented with different types of projects. Thank you.
Thank you, Vassell. So at this time, I'd like to ask if you have any questions to go ahead and enter them in the question box. And I would like to ask the first question. Vassell, what are the main challenges that were faced during the implementation process of building this hospital?
Well, the main challenge was change management. To implement different concepts and techniques between the subcontractors and even part of our people at site is not easy. So it needs training. It needs, like, we prepared like a war room in order to align our people towards the same concept. In addition to have a unified deliverables from the subcontractor, that was another challenge. The third challenge, I can say, the integration between different systems and different formats. Our system, C3D, is able to read from different systems, and it's able to integrate information coming from different sources. So yeah, maybe I can say those are the main challenges we faced at that project.
It was all about the details. So what are the benefits that were gained from applying this system of controls that you went very in detail with all the graphics, the colors, and whatnot, in order to make this project work?
Well, the main benefits are related to our control staff at site. our people at that project specifically, they can tell that we managed to reduce our control manpower to less than 25% from other similar projects. Also, we managed to increase the productivity of our crews. In addition, this project, we eliminated most of the conflicts happening between subcontractors and their claims, expected claims. We have minimal number of subjects raised at that project because of this system. Besides that, and since we put all our crews in sequence and we managed their work, and there was like a clearance between those subcontractors, so we are not able to repeat the job, the quality of the job, it was high. And we end up with minimal number of punch items compared to other types of projects. Yeah.
Excellent. So another question associated again with the challenges, but this one is specific with transitioning. What were the challenges associated with transitioning the implementation as well as the training of the technology associated with the implementation?
Very good question. Yes, actually it took us around 3 months to accomplish all the elements related to this system, because we need to start building the model, and the model, it takes time to finish, so we give priorities for the authoring team, and in parallel we train our people at site on how to utilize the information coming from our modeling team, besides having coordinators with the subcontractors in order to align them and to agree with them on their deliverables, as I mentioned, through the EDI meetings. Besides that, having the major control team, the planning, the cost control, and the subcontract control departments, utilizing the system by using different levels of training sessions and deliverables, different types of deliverables, and customizing those deliverables accordingly. And we have a permanent system specialist that customize and do ad hoc reporting according to our project control team.
Okay. What is the computer system that you used? You referenced the word system on a few instances.
Yes, out of market we used Revit and Primavera. And the other systems, actually, they are in-house systems. We use Talisman for hosting the data as a data bank and to control the revisions. We have VBC for document management, and we use C3D Planner for progress monitoring and advanced work packaging. And we have C3D Atlas for quality control, besides Progmon for cost control.
Okay.
So it's a number of systems integrated with each other.
Absolutely. So overall, how much time did it take to complete the front-end loading specific to this project schedule?
Well, this is an ongoing process. Because as you can tell, the project, it's composed of a number of activities, and each activity it's related to a number of different work packages. So it's like a many-to-many type of relation. And for each work package, we need time to eliminate their obstacles or elements within the front-end loading lists. So we used to do this checklist on a monthly basis, and we used to clear out topics for the next 3 months. So it's an ongoing process.
Okay.
We do it through the whole project life.
Awesome. How has this process been received by the subcontractors, the partners, and all of those other people who are part of the build process?
Yes. As I mentioned, first we started with the electronic data interface meeting to align everybody on the same requirements, deliverables, formats, and so on. Then we provided them with windows to deliver their deliverables by using VPC e-rooms. We have our system is web enabled for document management, and it allow the subcontractors to post their deliverables within those e-rooms with all the EDMS requirements from acknowledgement and notification and so on. In addition, the C3D system gives them a window, for our subcontractor, to follow their progress and to register even their progress using the digital pen. We allow them to do that.
Uh-huh.
So the idea here is to allow all parties to share with you your implemented systems.
So as it relates to subcontractors and as well as the overall build, how is materials defined, identified, managed, controlled through the entire process, whether it's brought in by a subcontractor or already on site?
Yes, actually we have Talisman. It's one of our legacy systems that would allow us to control the material delivery, the warehousing, and the execution of the material. In the beginning, we start with the deliverables coming from our modeling team, the authoring team, BIM authoring team. They should deliver us the objects with their types, with their specs, and with their tags. From their tags, we can sum up the quantities required per each commodity, per room, per system, per floor, and we can aggregate that on different levels. So we'll be able to tell from a certain commodity what is the total quantity we needed as an engineering quantity. We can compare it to the BOQ quantity to be able to say if we are exceeding the budget or we are within the budget. In addition, we are able to do like an agreement, so we can have good rates from the suppliers over the whole quantity, with ability to control the call-offs for those material to be delivered at site. So we have a full material tracking system, we call it Talisman, and C3D is integrated with this system. So we can reflect the output of the material control over the model even. Yes.
Well, thank you so much for sharing this information. It's been very insightful to learn about the massive amount of systems that technology is being implemented to make things better, to make the complex simpler. I would like to thank everybody for joining us, and if you would like to revisit this or share the presentation with your colleagues, you will find this recording on the FIATech YouTube channel. Be on the lookout for more webinars as we have a couple more scheduled throughout the summer. Thank you so much and have a great day.